Okay, here's a slightly more interesting question. So we have the position function. And so like we always like to get our bearings and figure out what everything stands for. So T is time. We start looking in here, our units, looks like time is measured in seconds. So this tells us how far, looks like it's measured in meters, how many meters this has traveled based on the number of seconds that have elapsed. So find the velocity. So we want the speed. So if this is position, speed would be the rate of change of the position. And thankfully, in calculus, we have a very nice thing for rate of change. That's just asking for the derivative. So the derivative of the position function will give us the velocity function that we're looking for. Then it's just power rule, so it looks like a reasonably doable derivative here. This is 3t to the third, so that'll be 9t squared. And then 4t, the derivative is 4, and the derivative of constant 0. So it looks like we end up with 9t squared plus 4. And then they want to know what's the velocity at time t equals 3 seconds. So if we plug 3 into that function, we get 9 times 3 squared, so 81 plus 4, so 85. And you can do it in your calculator. Okay, so then we want the acceleration. So if we think about acceleration, acceleration is how fast your speed is changing. So it's another step up the rate of change kind of ladder. So we want the second derivative. Well, we've already taken the derivative once, so if we take the derivative again, and we get 18t, and then the derivative 4 is 0 since it's a constant. So it looks like 18t is our acceleration equation. And then they want the acceleration at time t equals 3 seconds. So if we put t equals 3 into our function that we just came up with, so 18 times 3 is 54.